Before letting you proceed to 4.2, I just want to talk about pseudo-philosophy. It really isn't here in C++, and that is the idea of truth. What does it mean for something to be true, and what does it mean for something to be false? At its core, we should start thinking about true and false algorithmically. So what does that mean? It means that true is a correct statement and false is an incorrect statement. So here on page 153, we have table 4-3, and we have true or false, and we want to see how those are evaluated. So the very, very first one of those is x. Before we get into it, we should mention here that x has a value of 10 and y has a value of 7. So the very first one, x is less than 7. You know in your mathematical mind that 10 is in fact greater than 7. So x less than 7 evaluates as false. Next, x greater than y. You know again that 10 is greater than 7, so that evaluates as true. X is greater than or equal to y. And again, you know that 10 is greater than or equal to 7, so that evaluates as true. Less than or equal to, you know that 10 is not less than or equal to 7, evaluates as false. And not equals to, this one evaluates as true because 10 does not equal 7. So these are what are referred to as truth tables. And I'll tell you, in the campfire stories of yore, when it came to how it was that we thought about C++, when we exclusively thought that programming was the realm of mathematics, and a device like an iPhone comes around and then people go like, oh, we can do a lot more with that. But we used to spend a ton of time, for whatever reason, doing these truth table expressions, and I'll tell you, I don't find a ton of value there. The thing that I will tell you does have value. And so let me just scroll down to that here. Is this here? It is table 4-4, and it is page 155. And you can see that it's important to note that x or true rather and false are also assignable as a value, and that would be 1 for true and 0 for false. So here in table 4-4, and again, this is page 155, we have x equals x less than y. Now, before we talk about that any further, what I would suggest is for you as the developing developer, we here have an opportunity to force orders of operation by putting parentheses around things. I would suggest to you that it is a good programming practice to slap a set of parentheses around x less than y, because getting in the habit of doing so will keep you in the habit of doing so. And later on, when you have potentially far more involved logical operations, potentially, you'll just automatically wrap things that you want wrapped together inside of their parentheses, and you will escape some of those issues of logic that happen. And I know some of you have already seen those logical issues that have come up as an order of operation and the order of precedence, because I've seen it from last session or 2 sessions ago rather, in the interest rate problem. I believe it's 319. The textbook actually provides you with the formula for compound interest, which is great because I think that that's grisly math and would be unfair if it wasn't right there in the textbook for you. But as many of you know from having reached out with questions, I know I have the equation right, but it's not coming out. Yeah, that's because we don't have parentheses around things. So here, 155, table 4-4, I would suggest when you have x equals x less than y, go put those parentheses around there immediately so that you don't lose track of what it is that you're trying to evaluate here. It is as much, if not greater, an issue for you than it is for C++. So when I'm evaluating x equals x less than y, what happens is the right-hand side of the operator is evaluated first. So the right-hand side of equals goes first. Is x less than y? Is 10 less than 7? No, that evaluates as false. And false has a value. The value of false is 0. So after this expression is done with its relational operator and with its assignment statement there, so the relational operator on the right-hand side, the equal being the assignment, what we have is x will take a value of 0, so a numeric value because of the false evaluation on the right-hand side there of the operand. So that's something to be aware of. Next, we have, I can see out the result of an operation. So if I am testing for is x greater than y? Yes, x is greater than y, so the result would be 1, 1 for true. So the result of the cout statement is 1 because the x greater than y evaluates as true. True has a value of 1. So I'll let you go through the rest of that table. I think I've beaten that horse quite well enough. But it is worth noting that you have the ability to test for the truth or the falseness, I suppose, of a statement. And they have a numerical value that you can test. 1 for true, 0 for false. Numeric testing works out really great for this.